So inverse functions, our last section of this chapter, everything and anything about functions. Let's get into it. Now, here you go. You need your graphing calculators out, just like it says. Graph the functions on your calculator. Complete the table for each function. So there's really no real work that you have to do except type those in and fill in the table. So let me give you a minute to do that. Everybody's typing. Okay, so you probably have this first table already filled in, or really, if you really didn't want to go through the process of putting them in y equals and pulling up the table, couldn't you just mental math it and put 0 in for x, 1 in for x, 2 in for x, 8 in for x? Might be a little quicker, up to you. What did you get when x is 0, y is what? And then x is 2, y is, and your final value was. And again, if you put 8 in for x, 3 times 8, 24, minus 1, 23. Now, with the fractions, I know how you love fractions, no judgment. You probably want to put that one in y equals and get the table pulled up for that. So I'll give you a sec if you're still typing that guy in. I already see you guys filling in the tables. Now, I know it seems like kind of random numbers here maybe for x in the table, but clearly I'm trying to demonstrate something. Bless you. What did you get for your first y coordinate? Second y coordinate. Interesting. And this one pairs up to what? So again, I know that kind of seems random, the x's, but what am I trying to show to you? What's the difference in the tables? The inverse. X became y, y became x. This is one way you can see two functions are inverses. The ordered pairs reverse. So where it says compare the tables, I mean, I'm not going to write an essay here. I'm just going to say x and y switch. So clearly I picked these two equations. I didn't just randomly pick them. They are inverse functions. They're inverses of each other. So one of the things we're going to do today, they're going to ask you to verify two functions are inverses by a table. So that was pretty easy. They're going to have us find the inverse. We're going to figure out how to figure out what function g should be if they only give you the first function. And then we're going to look at some graphs of inverse functions too. So anything and everything to do with inverse of functions. Now, the other thing I'm going to talk about, one-to-one functions. There's also another type of function called onto functions. We're not going to get too carried away. I'm going to show you how to figure out if one is one-to-one and what exactly a one-to-one function is. Okay, inverse functions. F and G be two functions. They're inverses of each other if. Now, here's a throwback to Friday. The other way you can tell that they're inverses, besides the ordered pairs doing a swap, is you can do your composition, F of G, and it should equal x. Just x, not 5x, not 7x, x. And that should work the opposite direction too, if you do g of f. So that is another way to prove or verify that they're inverses of each other. So, and they're going to ask you to do both things. They're going to ask you to do compositions. They're going to ask you to do the tables. They're going to ask for all of it. So it just depends on the problem. We just got to read closely today. Now, like I said also, one of the things they're going to ask you to do is to actually find that second function, find the inverse function. So just like we did on the ordered pairs, we're going to interchange x and y. We want it back into function form, so I'm going to solve for y. Now, and then we're going to get fancy with our notation. I'm not going to leave it y equals. We're going to use this. Now, that -1 is not an exponent. That means the inverse. That is the mathematical notation for inverse. So when you look even at your graphing calculators, let me pull it up here. On the side here, that x to the -1 button, that didn't even say that. That is really your inverse key. That is not an exponent. That's your inverse key. Just so you should know. All right, let's see what we have. Find the inverse of the function. Verify, so they want you to do the compositions. So we have 3 missions here. We have to find the inverse of that. I have to do the composition, and then I have to do the composition the other direction. So here we go. Let's first start with finding the inverse. Now, I know you probably can skip this part, that f of x, of course, is y. I don't know if I'd really even bother rewriting that. Now, when I go to find the inverse, I'm going to switch x and y. Everything else stays the same. You only switch x and y. Then I'm going to solve for y. I'm going to take 1 off of each side, and then we'll have to divide by 2. Now you could of course put all over 2 over here. I just separated it out into individual fractions. Now I'm going to be fancy here. I'm not going to leave my answer blank equals. I'm going to say F inverse equals, and I'm going to put this as 1/2 x minus 1/2. Okay, so that was mission number 1. Remember, there's 3 on this problem. Then it says it wants you to verify them. Remember, that's the other notation. We're used to probably seeing it written like this for the composition. We have to do it both directions. Okay. So remember, right into left, F inverse into F. So I'm going to take my green expression and plug it into the red one. So I'm going to have 2. I'm going to replace x with 1/2 x minus 1/2. And then, of course, my f function, we have to add 1 to the back of this. Now, if I didn't mess up our green inverse function, we should end up equaling x. This is your check or your safety net, so to speak. So I'm going to have x minus 1 plus 1. Yeah, looks good. Okay. If I didn't get x, I messed up finding that inverse function. Now, here's the yuck part. It has to work both directions. So now we have to do f inverse of f. So right into left, f into f inverse. So now I'm going to take the red f and put it into the green. So the green function says we've got 1/2 times the input, but I'm replacing the input with our red f function, 2x plus 1, and then minus 1/2. Now again, long as my inverse function is correct, this better equal x, otherwise we have an error somewhere. All right, plus, it looks good, it looks good. Got it. So the first, I want to say, I don't know, 3 problems, maybe it's 4 problems on the homework, are going to be just like this. These are the most time consuming of the day because you have to not only find the inverse, but you have to verify it both directions. So once you get through the front page of the homework, I promise it gets easier, faster. All right, show f and g are inverses algebraically and by creating a table of values. Okay, so here's the nice thing. They already made the inverse. They did the green work for us. I don't have to repeat that, okay? But I do have to complete the verification. So I have to do f of g and g of f. So here we go. First, of course, right into left, g into f. So this very lovely cube root into the f function. So we have my cube root. So taking a look at my f function, it wants you to cube that and then add 5. Now, I don't think we have to get carried away here. I think we can do a lot of the simplifying in our heads. The cube root and cubing, of course, would cancel. And then the 5s also cancel. If you do not get x, something has happened bad here in your algebra work, okay? And of course, we have to verify it both directions. Got it. So I'm going to f into g. So now I'm going to take this x cubed plus 5 and put it into that cube root. All right, so g function, we're going to take our input, x cubed plus 5, and then don't forget you still have minus 5 behind it. Now, I mean, I don't think we can really need to write anything else. We can just simplify it because those are going to cancel, cube and cube root. We got it. So that is the verifying it algebraically. We're still going, because it says numerically by creating a table of values. So it also wants you to verify it, showing you the t-charts are switched. I don't need 20 points. I'm just going to do 3. That's kind of my rule of thumb. Now, it's up to you if you want to get those points off your calculator or you just want to mental math it and plug them in. I'm just going to mental math it. I'm going to start with F. Now, you got the x cubed in F, so I'm going to pick small numbers here since I'm doing this in my head. Let's start at 0. 0 cubed, 0 plus 5. Then I'm going to put 1 in, nice and easy. 1 cubed, 1 plus 5. And hey, let's do 2. Why not? What's 2 cubed? 8 plus 5. 13. Okay, so then we have to do the table for G. None of this is crazy difficult. It is time consuming though, I will tell you that. X, Y, there we go. Now, it might seem kind of random, but remember we want to show the t-charts are switched, so I'm going to start with 5. Which again, I want to show they're switched. So if I put 5 in here, G, 5 minus 5, 0, cube root is 0. We'll check. Then I'm going to put 6 in. 6 minus 5, 1, cube root of 1. And I'm going to put 13 in. I bet you can guess the answer. 13 minus 5, 8, cube root of 8, 2. So you may have different points, obviously, in the homework or whatever. That's fine. Rule of thumb 3, just show me that the t-charts are reversed. You can get them in your head, off a calculator, doesn't matter to me. All right, let's take a look at this. Oh, now it's graph. Okay, good. Show f and g, oh gosh, inverses algebraically. So f of g, g of f, we're still going on that. And then, of course, we're going to do the graphs. All right, let's do f of g first. So g into f. So now don't get caught up on g where it has that x is greater than or equal to 0. I am going to talk about that when we graph it. But for right now, I'm just going to put g into f here. So I'm going to have the square root. My input, x squared plus 4. Don't forget you have minus 4. I don't think we probably need to get carried away with much, a whole lot more work here because 4's are gone, square and cancel. We got x, that's what we're after. Okay? Make it easy, make it simple. Okay, other direction. F into g. So now I'm going to put the square root into the g function. I'm going to start with the square root of x minus 4. G says square and add 4. Well, of course, the square root and squaring cancel. Probably don't need a whole lot more work here. We're going to have x. All right, now we're to the graphs. Now, just because for all that composition, I wrote all over this. Let me erase this. I kind of made a mess here. So let's start with f. I'm going to do f in purple, just to kind of color code it here. Now, you can totally, if you want, plug that into your calculator, draw the graph, get a few points, and plot them. I'm going to go old school. I'm just going to make the t-chart myself because I think I can pretty easily. Plus, we can review for our upcoming test. Hey, let's talk domain. What numbers you're putting in for x? What types of numbers can you not square root? Negatives, I hear it. So I'm going to start with 4. Because what's 4 minus 4? Square root of 0. Got it. All right, let's put 5 in. I didn't want to do 3 because 3 would be a negative. Let's do 5, though. I feel good about 5. 5 minus 4, 1, square root of 1. Now, you could put 6 in, but you're going to have a decimal, and we know I can't graph that great. Okay, so I'm going to get fancy. I'm going to do 8. 8 minus 4, 4, and the square root of that, 2. Got it. Okay, thinking about our test always. I am going to graph the other one. I am going to talk about the inverse. So let's review for our upcoming test. What is your domain of this function in interval notation? 4 comma infinity, left to right. What's the range, lowest to highest? What's the lowest? 0, highest, infinity. Hey, for fun, is it a function? Yes, because it passes what test? Vertical line test, which today, get ready, we're going to do the horizontal line test. Ooh, okay, all right, let me get g up here. I'm going to do that one in green. X squared plus 4. We do need to talk about this greater than or equal to 0. Now, you can, of course, put the x squared plus 4 in your calculator and graph it, but we should know what sort of shape is that going to make with the x squared. I see you guys doing this, parabola, but we're only going to have half of it because of this little note, greater than or equal to 0. So you know what? Work smarter, not harder. I know they're inverses. I'm just going to flip these points and graph them, okay? So I'm going to graph 0 comma 4. I'm going to graph 1 comma 5. I'm going to graph 2 comma 8. Got it. So we're only going to have half of the parabola because of this inequality. They only want you on the right side of 0, and here's going to be why, okay? So if you told me nothing else, you gave me no equation, no t-charts, no f and g, just that picture of the graph, I can look at that graph and be like, yeah, those are inverse functions. Here's how I can tell that from the graph, and you're going to have to tell this too. If I draw this diagonal line right through the middle of the old graph, I'm trying to draw it straight. Flashback to geometry. Those graphs are symmetric over that blue line I drew. If you fold them over the blue line, they match up. That's what makes them also be inverses, or how you can tell from the graph. Now, we got to be fancy. We got to use some geometry lingo here. I'm going to say they reflect And hey, this is part of our test. What's the equation of that blue diagonal line I wrote? Y equals x. Slope is 1, up 1 over 1, up 1 over 1, and the y-intercept 0. So that's a way you can visually just look at the graph and know for sure you have it right, because they will always reflect over that y equals x line. All right, moving on. Oh boy. Show that they're inverse. Okay, graphically. Okay, numerically. Well, this I think is going to be pretty easy. I think we should probably do this one all in our calculators. Because graphically, I don't know if we want to make the t-charts and do all this fraction work in our heads. Numerically, I need the t-chart to plot it anyway, and I need the t-chart to show it, so let's just do it in our calculators, okay? So I'm, of course, going to use that horizontal fraction bar. So however you got to pull yours up here. I'm going to type it in just as it appears, x minus 1. And then x plus 5. I'm just going to do F for right now. I'll do G in a minute, because I think we're going to have our hands full just with F. So you have two different pieces of the graph, okay? So let's look at the t-chart and see what we can get for any decent points. Let's see what we got here. So let's do, I'm going to do like -3, -2, -2, -1. What else is on there? Anything like 1, 0. So that kind of gives you this piece of the curve. So I probably need to scroll up on my t-chart to get that other piece of the curve. So let me scroll here to the left. So let's maybe try like -7, 4, -6, 7. 7, 4. -6, 7. Okay, I'm just going to kind of draw it. A little rough sketch there. Let me give you guys, let me put the picture back on, give you a second. Now, I needed the t-chart to get the points to draw the graph, but they also want you to show it numerically. So I'm just going to throw the t-chart back up here, and I'm just going to pick 3 points here. I'm not going to get carried away. Let's see what we got. We're going to pick some nice numbers. I'm going to do, let's see, -8, 3, -7, 4, and we had -6, 7. You can have different points in yours if you want. I do not care, okay? Now, that was only F. We got to do G yet. Okay, pull up your calculator. Let's go back into y equals. I'm just going to hit enter. I'm going to go ahead and put G on. I'm going to leave them on the same graph. I'm going to use the horizontal fraction bar, but before I pull it up, I'm going to put in the negative. I'm going to pull up my fraction bar. Now I'm going to type in my top, 5x plus 1. I'm going to right arrow. What is it? X minus 1? Yeah. Come on, graph. Enter, graph. Okay, let me give you a minute to pull up the t-chart, get some points, and get that plotted. So this one's just a little bit obnoxious because you have so many pieces of these graphs to draw. So you're looking at the red numbers now in your t-chart. I'm going to, of course, steal the picture because we've all seen my artistic skills. It's such a nice graph I drew. So nice. Maybe it doesn't have to be perfect. You're finishing getting your graph. I'm going to go ahead too and do my table here because they want me to show that. Obviously on the table it was 3, -8, 4, -7, 7, -6. You might have different points, that's fine. Don't forget too, just check it. I can tell you just from the picture, if I draw on that y equals x line, pretend I'm drawing straight, if you reflect it over that green dashed line, these pieces are going to flip over each other. The far pieces will too. So again, you can always do a quick visual to make sure your graphs are inverses and you didn't mistype anything or anything, went off the rails. Any questions on that? All right, last thing I have for you. We are going to talk about one-to-one functions, what they are, how to tell if it is one. It's super easy. And then really the last example is just trying to help you with your homework a little bit. So one-to-one functions. No 2 elements of the domain correspond to the same element of the range. I don't think that's very clear. Okay, so let's just back up the truck and talk about a function. Remember the definition of a function. each input can have exactly one output. So if you put a number in for x, you only get one answer for y. We know that, we've been covering that. Well, now to be what we call a one-to-one function, besides the fact the x's cannot repeat, the y's can't repeat either. Nothing can repeat. So I'm just going to add a little note here. X can't repeat, neither can y. No repetition in ordered pairs. So for instance, you don't have to write this. I'm just going to give you a for example because I can't help myself. Now that would be an example of a function. -1 is paired with one number, 3 is paired with one number, 4 is paired with one number. That is not a one-to-one function because I made the y's repeat. That would be a function, not a one-to-one function. I would have to have this paired up with something else. So no repetition in x or y. Now, why does this matter? Why do you care if it's a one-to-one function? Only one-to-one functions have inverses. Does an inverse exist on it? If it's not a one-to-one function, there's no inverse. It just doesn't happen. You can't make it work. Now, we're not going to get carried away here on how to tell if something's one-to-one. There's a nice, easy test for it. Horizontal line test. The vertical line test for horizontal, okay? If every horizontal line intersects the graph at most one time, and this is the mathematical symbol here at the end for one-to-one. Who wants to write out all those words? It's too much. So that's the mathematical symbol for one-to-one. So we're just gonna, super easy, test it. Use a graphing utility, graph the function, determine if it's one-to-one, and if so, has an inverse. All right, well, let's graph it here. Let me clear out all this stuff. All right, 2x raised to the, and I'm just going to do 1 divided by 3. I'm just going to keep it easy here. Hit graph. So the first thing I'm going to look at is, does it pass the vertical line test? Is it even a function? Pad once. I'm a little worried here in the middle. Just like on your phones, you can zoom in on these graph grids. If you hit zoom at the top, and I'm just going to hit in, number 2, it pops the cursor up. That's honestly where I want it to zoom in, is right there in the middle. If it was someplace different, I'd move it. That works. Oh, okay. So there's a break in it. So it is not going to hit in the middle twice there. There is a break in the graph. Now I'm going to zoom back out. I'm going to do my zoom 6 standard. So now I'm like, okay, it does pass the vertical line test. It won't hit twice in the middle because there is a break. So it is a function. Does it pass the horizontal line test? Will it hit more than once? Nope, good to go. It is a one-to-one function. So I'm just going to say yes, one-to-one. I'm not going to get any more carried away than that. And then just the reason we're using this, only one-to-one functions have inverses. That's a quick, easy way to tell. All right, last problem of the day. This is to help you with your homework, okay? Those are the exact functions in this example that's in part of your homework problems. So I'm going to save you some work here, okay? You can flip back to your notes and use this. All I did was kind of change the numbers in A, B, and C. So it says use the functions, blah, 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 to find the indicated value. So I'm looking at A, I'm like G inverse and F inverse. Okay. G inverse and G inverse. Okay. So all of these have inverses on them. They didn't give you the inverse functions. Boo. Okay, we got to make them. So let's make, that's why I left you some room here. I'm going to make F inverse first. Now, of course, to do the inverse, we switch X and Y. We know F of X is really Y, so I'm going to make it X equals 1/8 Y. I'm going to solve for Y. Let's add 3. And of course, what's the quickest, easiest way to get rid of the 1/8? Times by 8. Pretty much do it in our head. Okay, so I'm going to write it up here so it's nice and pretty. So I'm going to do 8 times X, 8 times 3. And there is my inverse. So you do not have to recreate this work I just drew in purple on the homework. Just use your notes and do the calculations. I'm trying to save you some work here. G inverse. Same spiel. Switch X and Y. We know G of X is Y, so now X equals Y cubed. That's very dramatic. Let's get rid of the cubing, of course, cube root. And then, of course, I'm just going to write it nice and pretty. G inverse equals the cube root of x. So the purple and green work, you do not have to rewrite on the homework. Just flip back to your notes and use those functions. Now it's easy, okay? Composition, remember, right to left. So first thing you're going to start f inverse of -3. So I'm going to go to the purple function. I'm going to put -3 in for x. You could probably mental math it. Probably don't need to write anything. You know, I can't help myself. I'm going to write 8 times -3 plus 24. What do you got for that? 0. Now we're going to take 0 and put that into G inverse. Over to the green. Probably can do that in your head as well. What's the cube root of 0? 0. Final answer is 0. Of course, I'm writing way more work than I expect you to. But you know, I can't help myself. Okay? So once you have those inverse functions made, I mean, that's light work. That's super easy. It's getting those inverse functions made. All right, let's do B. Now, I didn't have a typo here. It is G inverse of G inverse. I haven't lost it yet. Right to left. G inverse of 4. Now, G inverse of 4, I'm going to put a 4 in there, so I'm going to cube root of 4. Okay, okay. And now I have to, of course, put that in G inverse again. So I'm going to have a cube root of 4. Seems weird, but I think we can clean it up. Okay, let's see if you remember from Algebra 2, you can combine that to one root. What number root would it be? I'll give you a 50-50, 6 or 9. Nobody wants to guess. 9, it's the 9th root. See, I knew you knew it. It's right on the tip of your tongue. You multiply the roots together, 3 times 3. Okay, C. G inverse, F inverse. They didn't give us the number or anything. Okay, so G inverse F. So we're putting F inverse. Oh, okay, we got this. So we're going to put the purple into the green. That's all it is. Oh, well, that's going to be pretty easy. We're going to end up with a cube root of 8x plus 24. Done. Got it. Okay. So again, you'll see on your homework, there's some exact equations. Do not do the extra work of the inverses. Just steal them off your notes and do the calculations. The first page of the homework, I'm just going to be honest with you, is the worst because you have to find the inverse and do the verifications both ways. Enjoy that.